Given that P and Q are points with coordinates P, 1, 3 and Q, minus 1, 4, the position vector PQ is. Alright, so before we get straight into the answer to this question, we're going to just take up 2 or 3 minutes at the beginning just to do a little discussion about general vectors. Good? So, we have the point P, capital P, and the point Q, capital Q. Both of these points are associated with position vectors. Position vectors denoted by common P with a little line under the P, or sometimes you leave the line out, right? Don't matter. So let me leave the line out just for the sake of convenience. So your position vector is P, common P, and your position vector for the point Q is common Q. Alright? Position vectors, of course, being defined with reference to the origin. The only vectors that you could refer to as a position vector are vectors defined with reference to the origin. Any other vector would be what we refer to as a displacement vector, right? Which we wouldn't deal with too much now. So you have the same vector. If it is defined with reference to the origin, it will be a position vector. If it is defined with reference to some other point on the Cartesian coordinate plane, it will be a displacement vector. More about that somewhere else. So anytime we're talking about position vectors, good, we could draw a simple diagram. If you have 2 vectors or 3 or 4, however many you have, then you have O as a point of origin. We could have your position vector P. So this would be a position vector P. We'll get into that arrow there in a little bit. And this is your position vector Q. So in other words, the position vector P is a vector that moves any point from the origin to the point P. Right? We know in this case that P is the point 1, 3. And in this case, Q is the point minus 4, 1, 4. Right? So, some more notation now. We could say then that P is the point, let us say, I plus 3j. Just introducing this to some notation here. We could say Q is the point minus I plus 4j. We could also write it as P is equal to 1, 3, and we could say that Q is equal to minus 1, 4. Alright? So this is one type of notation for vectors. This here is the other type of notation for vectors. Whichever one you feel more comfortable with, you use. But both have their different uses in different situations. So it is better to have some level of familiarity with both forms of notation. Question. We want to talk about the position vector PQ. So we know that the position vector, alright. We wouldn't get into the argument now, right? PQ is not a position vector. Let me just say that. PQ is not a position vector. PQ is a displacement vector. A displacement vector meaning that we're taking the point from P and we're displacing it until it gets to Q. The only time you refer to a vector as a position vector is when the displacement begins at the origin. Alright? So just bear that in mind. We're not going to get into any arguments here about semantics and words and stuff. Just know that a position vector is always defined with reference to the origin. Anything else is a displacement vector. Good? So in this case, you have a displacement vector PQ. In other words, we want to start from P and end up at Q. But we want to do it with reference to the 2 position vectors that we have already. So in other words, we're not going to be making a straight jump across from P to Q. We have to use the position vectors that we have. So if we're starting from P, then we will be moving in this direction. We're moving from P back to O. In other words, we'll be moving in the opposite direction to the position vector P, which is defined in this direction. So we're moving from P to O. We're going to write the 2 forms, P to O, And then once we get to O, we're moving from O to Q, which is in the same direction as the position vector Q. So you move from P to O, so we can say that PQ is equal to PO plus OQ. In other words, PO will now be minus P, OQ will be plus Q, right? Which we could then write over nicely as Q minus P. And if we want to find Q minus P, we have the notation here. Minus 1, 4, minus 1, 3, minus 1 is minus 2, and 4 minus 3 is 1. So that the displacement vector PQ would be given in this format that they express the answers as, would be given as minus 2, 1. Alright, so in that case, the answer will be answer C.